Hello, everyone. Welcome to Backyard Musings, broadcasting live from Apple Valley. I'm Steve.
I'm Scott.
Thank you for joining us this morning. Very interesting. A groundbreaking study published in January 15th in Nature by this year's Nobel laureate in chemistry introduces a potential game changer in snakebite treatment. You ever been bitten by a snake, Scott?
I have not,
No,
but I've
neither
been
have I.
I've been close enough to a snake that I could have been bit.
Yeah. Scientists have developed innovative proteins capable of neutralizing lethal snake venom toxins, offering a promising, safer, and more effective alternative to traditional antivenoms. This new approach promises to significantly improve outcomes for the millions affected by venomous snake bites globally, particularly in under-resourced regions. Would you like to know more?
Yeah, we don't really have that many problems here in the U.S., right? I mean, not like it used to be.
Yeah,
It's pretty much
we,
under control.
we got rattlers out in these
Oh, yeah.
hills right over here.
Oh yeah,
And I used to
Mojave
see 'em-
Greens, sidewinders. Yeah, we have a lot of
yeah.
rattlesnakes.
but we don't have that problem of people dying.
Well,
We've got
I
medical
guess
resources.
close enough. Yeah, you get bit, you don't take off running or whatever. You try to stay calm and hopefully get help. So yeah. So the World Health Organization reports that venomous snake bites affect 1.8 to 2.7 million people annually,
Wow.
which is a huge number,
Wow.
resulting in approximately 100,000 deaths each year and
Wow.
leaving 3 times as many individuals with permanent disabilities such as amputations.
Crazy.
Yeah, so I mean, compared to the amount of bites, that's a pretty small number, right? What is that about? That's less than 1%, right?
Right. 2.7 million, less than 1%. Yeah.
Yeah, so that's pretty small, but it's
Oh wait, that's 10%. 10%. More like about 5%.
oh yeah, okay,
Yeah.
5%. Oh
Yeah.
yeah, 2.7.
5-ish.
Okay, gotcha.
Uh-huh.
Thanks for that correction. So each year, and leaving them 3 times as many individuals with. Oh, I already said that.
Crazy.
The majority of these cases occur in Africa, Asia, and Latin America, where limited healthcare infrastructure worsens the problem. Currently, the only antivenoms used to treat snake bites victims are derived from animal plasma and often come from high costs,
Yeah.
limited efficacy, and adverse side effects. Venoms also differ widely across snake species,
Yep.
necessitating custom treatments in different parts of the world.
Yeah.
In recent years, however, scientists have gained a deeper understanding of the snake toxins and developed new ways to combat their effects. One such development is published today in Nature.
Yeah. So the black mamba, there is death, and there is certain death. You get bit by the mamba, it is certain death, unless you get treatment in time.
And they are where?
They're in Africa.
Yeah,
A mamba.
I ain't going there. So.
No, I've seen on YouTube where they show lions, male lions, that get bit by mambas, and they just kind of clinch up, all tight, and then they die. It's painful. A team led by 2024 Nobel laureate in chemistry David Baker from the University of Washington School of Medicine and Timothy Patrick Jenkins from DTU, the Technical University of Denmark, used deep learning tools. I don't know what that means. Deep learning tools to design new proteins that bind to and neutralize toxins from deadly cobras. The study focuses on an important class of snake proteins called three-finger toxins, which are often the reason antivenoms based on immunized animals fail.
So while not yet protected against full snake venom, which is a complex mixture of different toxins unique to each snake species, the AI generated protection from lethal doses of three-finger toxins in mice.
Nice. Yeah. Love it, man.
Yep, 80 to 100% survival rate. That's pretty good.
Yeah.
Depending on the exact dose toxin and design protein. These toxins tend to evade the immune system, rendering plasma-derived treatments ineffective. This research thus demonstrates that AI-accelerated protein design can be used to neutralize harmful proteins that have otherwise proven difficult to combat.
And we're just seeing so much from AI, and at first when AI came out, there was a lot of talk of how harmful it could be. And I thought that it would lead to Terminators, which it hasn't yet.
Well, it hasn't, at least that we know of, right? But it's anything else, right? Opposition in all things, right? Good stuff,
We're
bad
getting
stuff.
good stuff from it.
Yeah.
Yeah.
So far, let's hope it stays that way.
Quote, I believe protein design will help make snakebite treatments more accessible for people in developing countries, said Susana Vasquez-Torres, lead author of the study and researcher in Baker's lab at the Institute for Protein Design at UW Medicine. I love that. If it can help underserved communities, save lives, I love it. Quote, the antitoxins we've created are easy to discover using only computational methods. They're also cheap to produce and robust in laboratory tests, said Baker. Oh, it's a win-win-win.
Even better.
Yeah. The scientists reasoned that creating proteins that stick to and disable snake toxins could create several advantages over traditional treatments. The new antitoxins can be manufactured using microbes, circumventing traditional animal immunization and potentially slashing publication costs. You know how they milk these snakes as they put their teeth over the
at least for rattlesnakes.
It's
anyway.
like milking them.
Yeah, they put them over like a jar or a brim or something, and
they just
squeeze
milk
it out.
Yeah.
But there are more disadvantages, explains Timothy Patrick Jenkins, an associate professor at DTU Bioengineering. Quote, the most remarkable result is the impressive neurotoxin protection they afforded to mice.
Let's save the mice, right?
Yeah, and mice are that's a prime meal source for snakes, right?
Oh yeah.
So rodents.
Yep.
So small, in fact, that we expect them to penetrate tissue better and potentially neutralize the toxins faster than current antibiotics. And because the proteins were created entirely on the computer using AI-powered software, we dramatically cut the time spent in the discovery phase.
Yeah, that's keeping the cost down.
Yeah, that's cool.
Although these results are encouraging, the team stresses that traditional anti-venoms will remain the cornerstone in treating snake bites for the foreseeable future. The new computer-designed antitoxins could initially become supplements or fortifying agents that improve the effectiveness of existing treatments until standalone next-gen therapies are approved. According to the scientists, the drug development approach described in this study could also be useful for many other diseases that lack treatments today, including certain viral infections, because protein design generally requires fewer resources than traditional lab-based drug discovery methods. There's also the potential to generate new but less costly medicines for more common diseases using a similar approach.
Quote, we didn't need to perform several rounds of laboratory experiments to find antitoxins that performed well. The design software is so good now that we only needed to test a few molecules, said Baker. Again, beyond treating snake bites, protein design will help simplify drug discovery, particularly in resource-limited settings. By lowering costs and resource requirements for potent new medicines, we're taking considerable steps towards a future where everyone can get the treatments that they deserve. Could you imagine that they come up with something? Let's say you're going to go out, you're going to be in an area like a hiker or a hunter or a fisherman.
Going into the backwoods.
That's going to be in an area that's got a high concentrate of snakes.
Yeah.
And so you get to pop a pill.
Yeah.
It's like
put it in your pack.
Like an anti venom pill or whatever.
Yeah.
So that's cool. This is amazing.
Yeah.
Hopefully it happens in my lifetime.
And hopefully it spreads to other things like, maybe they can cure cancer or some other diseases, through these proteins.
Yeah.
But wouldn't that be great to get rid of Alzheimer's?
It would. Alzheimer's and cancer. That would be amazing.
That would improve everyone's life, I'm telling you.
It would. But you got people out there saying, it's got to happen because the population would explode. That's baloney.
You don't know that. That's like would explode. Come on.
Yeah. Let people live out their life, being able to recognize their family members.
Last time I checked,
stay healthy.
Multiply and replenish the earth is still in effect.
Yeah, absolutely. We hear that a lot. So it's good advice.
All right, folks. Thanks for joining us.
Take care, everyone. Thanks.
Okay.